Welcome to Wireless LAN Weekly, a podcast focused on the wireless networking professional. We aim to educate, inform, entertain, and inspire. Get ready to listen and enjoy. Now to our host of the show, Keith Parsons.
Welcome back. This is Keith Parsons with WirelessLANProfessionals.com. Glad you could join us again. In today's episode, we have a high-tech topic as well as a more of a low-tech soft topic. Our first topic is Jon Freeman of Xirrus talking to us about high-capacity Wi-Fi and how to plan on that, as well as our soft skills segment is brought to us by Ed Schlichtenmyer. Ed and I go way back. We have a fun history doing a lot of things together, and when I thought of soft skills, I thought of Ed because he has great skills here, and he'll be talking to us about how to deliver better service as IT professionals. And of course, we have our definitions, rants, and elevator speeches thrown in there just for some fun. Stay tuned and enjoy the show.
Today's wireless networking definition from the CWNP Dictionary of Wireless Terms and Acronyms.
This is Joel Barrett, and today's term is four-way handshake. A pairwise key management protocol defined by a standard. In IEEE 802.11, the handshake confirms mutual possession of a pairwise master key, or PMK, by two parties and distributes a group temporal key, or GTK. So this is Joel Barrett for the CWNP Dictionary, and tune in again for the CWNP Dictionary Term of the Day.
Rant, pet peeve, what really bugs you? 60 seconds of complaining starts now.
Okay, well, what bugs me about things in the wireless industry? One thing that really bugs me for the last 2 years is non-existent or crappy public wireless services at seminars and conferences, and more specifically technology conferences. With the level that wireless technology is at, it's not that hard or that difficult to provide decent Wi-Fi access at an event. So I don't see why large events such as TechCrunch or Le Web in Paris or any of the other big conferences cannot provide the service consistently and over a level that is actually usable.
Things every wireless LAN professional needs to know. Gear up, buckle down, and stand by for the real techie stuff.
Hello again, this is Keith Parsons, and today I'm with Jon Freeman. He's the Area Vice President and Technologist with Xirrus. John's been around the networking industry for a very long time and knows all sorts of people and all sorts of stories, and glad to have him join us today. I'm sure we'll hear some stories from him. Today's topic is high-capacity Wi-Fi. Take it away, John.
Thanks very much, Keith. This is Jon Freeman. I'm one of the Area Vice Presidents for Xirrus. I'm going to talk specifically about the capacity requirements in Wi-Fi and what has driven those capacity requirements and what we're going to see in the future driven by those capacity requirements. And I'm going to start by pointing out that these are no different than the trends that we saw in wired networking, specifically starting with 1 megabit Ethernet and moving up to today where we have 1 gig and 10 gig drops for users. We see the need as a direct result of the proliferation of Wi-Fi devices. Most of us own a notebook today, or if we don't, we're getting one soon, which has a Wi-Fi radio in it. If you own an iPhone, it has a Wi-Fi radio in it. If you have an iTouch, it has a Wi-Fi radio. BlackBerry Bold, you have a tri-mode radio in it. And there was recognized back in 2003 some needs to handle this capacity, and there was several different approaches to try and address the need for higher capacity Wi-Fi. One of the questions you should ask yourselves in terms of what you're going to design for your network is how many devices is each user going to have? It's so easy today to think of our Ethernet cable drops, and we see those for each of our workstations. If we're running VoIP handsets, we are doing our voice via a IP Ethernet connection today. But with Wi-Fi, the proliferation of and need for those connections has increased and will continue to increase substantially. And there are some good studies that have shown we may see as much as 2.5 devices on average per user that will require a Wi-Fi connection. most of us approach the problem from what we already know. And if we go all the way back to the early advent of PCs that really started this distributed processing type of architecture, we saw accountants getting their VisiCalc and getting their 123 and taking that technology into the office with them, traditional IT groups being focused on mainframe applications and centralized process and management of the data architecture. But we rapidly saw the adoption of processing moving into the hands of the users. And that same trend happened in wired Ethernet, where we had centralized routing and centralized processing of the network, to now a distributed switched architecture where most of the processing is done in the closet closest to the user. We are going to see that same trend in Wi-Fi. And Wi-Fi started, we saw fat access points. Most of us have a fat access point in our home today where all the processing is done in the same device that contains the radio and antennas. Each of those access points really operating more like a hub than anything else. It's shared media, multiple people wait their turn in line to get onto that radio. And as we experience that more and more often, we can find problems in that architecture. And typically in the home, we don't see a lot of the capacity problems that we'll see in an enterprise or in an educational institution, specifically relating to the number of devices that connect. The more people you pile on to waiting their turn in line, the slower the connection is to the user. And a user's experience or expectation is going to be tied to what they already know. And it's pretty simple to look back at their home environment. If they're in a home, they've got one user, one connection, or maybe 2 or 3 people sharing a Wi-Fi access point, and they move into the office and they rapidly see 10 or 20 or 30 users connecting to that same amount of capacity, one radio supplying either in a G or an A standard 54 megabits of capacity, or with the new standard .11n, upwards of 300 megabits per second. Now, I will warn everybody that you want to strip out the management packets that make all of this Wi-Fi magic work. And typically the rule of thumb is to just divide whatever that total number is by 2. So split it in half, and that is usually what you're going to get in terms of maximum data carrying capacity for your users. You can take that number and divide it by the number of users you have in the network, and it'll give you a rough idea of the capacity each user is going to get. And I say rough idea because it's not a calculation that's totally accurate, because everybody is literally waiting in line. And there are situations where you might have a slow client, like a B client, running at 6 megabits per second, and on that same radio that supports .11n, a user that operates at 300 megabits per second. Imagine these speeds being a mileage on a mile per hour on a freeway. You'd have somebody running at 6 miles per hour and somebody coming up from behind them at 300 miles an hour and having to wait for them to get over. So a single radio is like a single lane freeway. Everybody waits in line behind that slowest client until they move off the road so others can pass or get to the front of the line and pass their data. The logical solution to solving that problem actually has been demonstrated in another technology. If you look at this cell technology today, cellular telephone technology, and you look back historically to where it came from, some of us might remember the old brick cell phones. Sometimes we even see them on old movies and get a good chuckle out of people toting those things around. But there was an argument back then that if everybody had a cell phone, the infrastructure or the cell towers, what we're talking about today, similar to the access points, would actually fail. And obviously, we have lots of cell phones today. I've got 4 kids. Every one of them has a cell phone, and the infrastructure supports it just fine most of the time. But if we look at a cell tower today, we can actually understand a little bit about what happened in the cell tower infrastructure to avoid that wreckage that would have normally happened comparing to the old cellular infrastructure. The old cellular infrastructure basically were single radio towers with omnidirectional coverage. Today, when you look at a cell tower, you see big rectangular antennas mounted on the outside of the tower. And if you actually look up and count the antennas, you'll notice some towers have 4 antennas. If you're living in a highly populous or dense area, sometimes you'll see as many as 16 antennas on a single cell tower, and sometimes even more stacked on top of each other. Each of those antennas tied to its own radio, its own amount of shared bandwidth. And each of those antennas providing a sector of coverage around that cellular tower. So where we had a single cell tower before with 1 radio, now we have as many as 16 radios, or 16 times the capacity as the old towers. So that's how they solved the problem. Today there are other ways in the Wi-Fi world of solving the problem, and there are architectures that solve it exactly in that same way. There have been other issues that have faced us in the Wi-Fi world as well. If we go back, moving out of cellular back to Wi-Fi, we had fat access points, really very little ability to manage them centrally. If you wanted to manage them, you would log into each access point, configure each access point to the characteristics that you wanted. And if you were a large business and you started adding lots of Wi-Fi access points, you have somebody in your IT group that is managing each one individually and probably spending their whole life doing that. A very arduous job, not a very efficient way of spending their time. And there have been technologies that help solve that, where you have a centralized controller that takes all of the packets moving across all of those Wi-Fi access points into a central controller that allows you to configure those access points from a single interface all at one time. So that person is not having to log into each access point, but the controller pushes out the characteristics they want for their Wi-Fi from a central point. Now, if you remember the earlier comment I made about mainframe computing, mainframe computing had its main weakness in that it had a single point of failure. And that's the primary problem with centralized management of Wi-Fi, is trying to eliminate that central point of failure. Most vendors have a good solution to that today, where you can put in redundant controllers. Not an inexpensive way of doing things, but certainly eliminates that central point of failure and allows a live failover in case of a hardware failure. Those technologies had another weakness in that all of the processing needed to come back to a central point. That central point of processing also meant you had to design the network to eliminate any potential choke points in the control plane and in the Wi-Fi controller aspect of what was going on with all the packet processing. So when you were designing the network, you had to make sure that you didn't oversubscribe your controller for too many access points. So there was a couple of steps and a certain level of expertise besides the radio frequency expertise in designing those networks that your IT department had to pick up on and learn and design into their network. And to some extent, some experience in the radio frequency aspects or characteristics of what was going on. And these characteristics were nothing like the wired Ethernet. Things like refraction and reflection, basically the behavior of RF signal. I once heard it said that RF works a lot like smoke or water, in that once it comes off the antenna, it just spreads everywhere. And it bounces off things as it propagates itself. In that, you actually create some things like multipath interference in that process. So there are materials in your environment that are going to take that RF signal, that radio frequency signal, and bounce it around and cause a interruption in the signal and potentially cause problems where packets need to be retransmitted. And the beauty of Wi-Fi is it knows how to handle most of those problems and can retransmit packets that end up getting collided with in the air from other users. But it is a different technology than wired technology, which typically can hear what's going on a wire. It knows when the wire is free and clear and when it can transmit. Wireless doesn't work that way. A radio needs to know it has free time based on a timer, or what's called the nav timer inside of Wi-Fi. So when somebody wants to communicate, they basically send out a packet. They obviously know that nobody else is communicating, and you'll kind of see how this chicken and egg logic works. But when somebody wants to communicate, they'll transmit a packet that says, I'm going to be on the air for X number of milliseconds or microseconds, transmitting my data, and everybody will take note of that, and they'll add to that number or that amount of time a random amount of time so that they don't try to jump on the air when somebody else does. Now, that requires everybody's radio to be able to hear everybody else's radio. And there are mechanisms where the access point can communicate that information to other devices as well. But if a workstation can't hear that information, that workstation is considered to be a hidden node. A hidden node is a bad thing because that hidden node can communicate when other people are communicating. So there's a lot of issues that need to be dealt with. It's why there is so much management traffic in Wi-Fi. There's a lot of work being done to keep an efficient network connection and as efficient a connection as you would have in a wired network. But none of this solves the capacity problem. And getting back to the original gist of the conversation, how do you solve for capacity? If you have 100 users, how do you get 100 users connected to your Wi-Fi network? Well, it's actually not as difficult as you would think. It really boils down to how many radios do you have available in that same area. So if I'm sitting in a cubicle, can I see one radio? Can I see 2, 3, 4, 10 radios? Each radio being transmitted on a separate channel. In Wi-Fi, we have the BG channels, which broadcast in the 2.4 gigahertz spectrum. Those channels are available in what are called channel 1 through channel 13. Quite frequently, I walk into businesses that are operating on any number of those channels. And in fact, you only have 3 of them available to you in the United States, channel 1, 6, and 11. You can use the other channels, but if you do, you'll end up creating interference with the other 2 channels that are available out of the 3 I originally mentioned. So if I operate on channel 3, I'm going to interfere with channel 1 and 6 and cause people to have to retransmit that are operating on those 2 channels. So to eliminate those retransmits, to eliminate the inefficiency in that, I have to use channel 1, 6, and 11. In the A standard, I have 24 channels. And they're typically referred to as uniband 1, 2, and 3. The beauty of A is that when you see the channel set, and they have numbers ranging from the 30s all the way up to the hundreds, each channel can be used, and you don't have to worry about channels you can't use or those channel separation problems in the BG. The guys in the IEEE did a good job of only allowing the channel set to be published that allows the channel separation you need. In other words, pick any channel you want in 5 gigahertz, and you have already been delivered the channel separation you need from any of the other channels you use. But the other effect is because you have 24 non-overlapping channels, you can turn them all on in a particular area with some limitations. And I have loaded up some graphics to depict some of these things. We have actually run into some customers who have tried to bolt together access points onto a board and provide multiple channels of coverage from a single point of installation. You can't do that because you have another problem with radio frequency, and that is what's called sideband interference, or near field interference is actually more accurate. And everybody's heard of near field interference. Whether you know it or not, you've heard it. If you've ever had your cell phone near your wired telephone, when your cell phone decides to communicate to the nearby cell tower, you hear near field interference. So you can't bolt all these things together. Well, not unless you have some design trick to fix that. And some vendors, one in particular, ours, has done a design solution that allows those radios to be packed all together into one design. That does require some tricks, the primary one being what's called the media access control layer of the radio. It's where all the 802.11 specifications and magic operate. But if the radios are able to all understand what the other radios are doing at any moment in time, they can avoid the problems of near-field interference inside of a single design. It's actually what a cell tower does as well. There are other vendors that provide some rules of thumb in terms of how close you can get access points together. General rule of thumb I always recommend is never put an access point within 50 feet of another access point. That will avoid the near-field interference problem. But it also causes another problem, and that is if, for instance, you're in a classroom situation, 50 feet is a pretty good distance, and most classrooms don't give you 50 foot of separation. So your best angle there is to light up one of your BG channels and one of your A channels. The channels are far enough apart in terms of spectrum, the BGs being in the 2.4 gigahertz spectrum and the A's being in the 5 gig spectrum. You can put one of each of those in a room and provide 2 radios of coverage. But if that same room has 50 users in it, now you're going to have, if you're lucky, 25 users on each radio. Now, the reason I say if you're lucky is that today Wi-Fi standard allows the clients to pick which access point they're going to connect to. There are some mechanisms vendors have built that allow the infrastructure to force clients to particular radios. It's fairly rudimentary today. Fortunately for all of us, there is 802.11 specifications being worked in the IEEE right now. One in particular that will actually see ratified this year, or I should say is being promised for ratification this year. And when that happens, our infrastructure will be able to command the workstation's behavior in terms of the speeds that they're going to connect and receive and transmit packet traffic at, and the radios that they're going to connect to. Huge boon to the IT organization, so that instead of today where Wi-Fi devices really are the king of the hill, they get to decide who they connect to. In the future designs, the future standard I just mentioned, the workstations will be directed to behave a certain way. Also a great thing from the perspective of the IT group, because most drivers in Wi-Fi devices today are not written to be very intelligent. A great example is the Wi-Fi Centrino radio. If you have one in your notebook, you may notice that even though it's a tri-mode radio, it supports the ABNG standard, and you might have a quad-mode Centrino that also supports N. More than likely, it will try to connect to the 2.4 gig frequency, even when a 5 gig radio is around. Some people say it's being lazy. I think it really is more a factor of the legacy it came from. But there are technologies in the architectures today, and you definitely want to validate this when you're looking at any Wi-Fi solution, that the infrastructure can direct those clients to the 5 gig channels when they are 5 gig capable. And as I mentioned, again, the simple way to add additional capacity is to have more radios in the area. One of the latest designs is the company design that we sell called the Xirrus Array. It actually includes 4, 8, 12, or 16 radios, and that's in a single device. So in any one area, you can have all of that capacity in one area, and solves capacity in probably the most efficient fashion that's available today. But as I said, there are other architectures that allow you to use single access points with omnidirectional coverage. Now, the other thing that you need to consider when you're putting other radios into an environment is the radio propagation behavior. So most of the access points shipping today have omnidirectional antennas built into them. there are a good number of the enterprise access point class devices that allow you to actually select the antenna architecture. The flexibility is nice. The downside is you have to understand antenna architecture and RF architecture as well as what Wi-Fi provides you to understand when and where to use those types of designs. If you are an organization with a limited staff of IT, you're going to be piling on more expertise requirements for them when you do that. So the more of the design that can solve these problems in the design itself, the simpler the ongoing maintenance and the initial design of your network is going to look for your initial implementation. But kind of wrapping this up, when you're looking at Wi-Fi, look at how much capacity you're going to get. Look at how much coverage you're going to get. Certainly, coverage will help you reduce the total number of active devices in your network. And think of each active device as something your IT group needs to look after and service and maintain over time. So the fewer devices they have, the more attention they can spend on the application level of your network, which is more than likely going to be the thing that drives profitability and efficiency into your business. So the more time they spend looking at the applications and how technology is being used to create efficiency in your business, the more bang for your buck you get from that cost center of your IT group. I know I'm probably talking to a lot of IT people. I know I'm a technologist myself, and we all love technology. But at the end of the day, our salaries are paid because we add efficiency into the organizational process and profitability into our business. And the better we do that, the more chance our business has to make a better profit. And the more times we present that opportunity for our business, I think the better chance we all give ourselves for advancements within our business as well. Thanks for listening to me. Take a look at our website, Xirrus.com, Xirrus.com, and you'll see a lot of our customers have done videos with us. Happy to talk to you. If you have any interest in our technology, please give us a call.
Thanks, John. This is Keith again. I appreciate your talking to us today about high capacity, and I found that to be, in my consulting practice, one of the things most people forget. They design for coverage, and as I say in my classes, coverage is easy. Anybody can get coverage by just adding more radios and turning up the power. But capacity and designing it to meet all of the goals is necessary. Another just a quick example. Coverage is to wireless what connectivity is to wired. You have to have connectivity. On a Cat 5 or a Cat 6 or even a Cat 7 cable, you have to have connectivity. In wireless planning, you have to have coverage. If you can't get a radio signal there, it's not going to work. But coverage alone is never sufficient. Just like connectivity on a wire isn't sufficient. You have additional specs: near side crosstalk, far side crosstalk, pinouts, twist ratios. In wireless, we have additional ones too, and a big one's their capacity, and you did a good job of talking about that. So if anyone wants to follow up, they can look at the show notes. There'll be some graphics there that he referred to, and thank you very much.
Interesting facts, little-known tidbits, things you might not have known, short little bits to set your mind a-reeling.
Keith Parsons here. An interesting fact. Did you know that in the original days of radio, the people who they hired to build and maintain antennas were those who built tall ships? Because their antennas had to be hundreds of feet tall in order to span the Atlantic, they used shipbuilders. And at one point in time, on an island off the coast of Boston, they had hundreds of tall masts, not for ships, but for radio waves.
Hey, being a professional means more than just knowing the technical. Now it's time to soften up and talk about the non-techie side for a minute. Slow down, put your feet up, and listen up to these items to help you on the professional side. Enjoy.
Hello again, this is Keith Parsons, and today I'm with Ed Schlichtenmyer. Ed Schlichtenmyer is an independent consultant. Ed and I go way back. We used to work together, back in CNEPA days, onto the NPA, worked with NUI Hot Labs. So Ed and I, good friends, we worked together for a long time. And I've asked Ed to come on today and talk about how to deliver better service. Ed's one of the people who is a consummate professional. He understands how to deal with people. And I thought, who better to have than Ed come and teach us a couple of things. So, Ed, let's get going.
Well, thanks, Keith. I appreciate that. Yes, we do go way back. I remember when we first met in, 92 maybe, or 93, and we were trying to get some services delivered at that time in terms of our particular market at that time, which was the CNEPA. Today, I just want to chat about some concepts around the idea of delivering better service. All too often, we fall into a heads down, I've got work to do, I can't be thinking about anything else. But the truth is, delivering better service is that work. And I have just a couple of topics I wanted to go over. The first is dress to the client. All too often, someone will wear something distracting or they'll overdress, and the bottom line is you don't want to make the client, that person that you're trying to provide service to, feel uncomfortable in any way, shape, or form. So the moral is, when you're going to a client for the first time, dress up a little bit. Gauge when you get to visit with the client what they're wearing, what the dress code seems to be at that particular facility, that particular organization, and then match that on your subsequent visits. It'll go a long way towards making the client feel more comfortable with you, which again helps you be able to provide better service.
That's a good point. I remember a consulting gig I was on in Hawaii, and one of the other consultants showed up, and I'm there in my standard Dockers and button-down shirt, and he shows up in a wife beater, little tank top, and running shorts and flip-flops. Shocked me at the time, but no one else who was there even minded. And afterwards, when I made a comment, they went, "Well, that's pretty normal for around here." So you're right. It's what's normal.
Excellent point. Yes, because it does go both ways as far as up and down.
Good. And go ahead.
I was just going to say, the other point I wanted to bring out is being a good guest. And that sounds kind of funny sometimes. But again, in line with trying to deliver better service, you want to engender some confidence with the client, and you want them to feel like they're being a good host. To that end, that includes things like when you first show up, and they offer you the washroom to wash up, by all means. Take advantage of that time to go in and wash and wipe your face or whatever you feel like you need to do, or nothing at all but catch your breath. You're letting them feel like they're providing you with a service, which will make it easier for you to provide them with the services they want later. Also, another good thing to do along those lines of being a good guest, if they offer refreshments, feel free and be encouraged to accept that offer. The host wants to make you comfortable. You need to make them feel comfortable too.
And that works whether or not you're actually thirsty.
It does. It does indeed. I've got a funny story about that. One time I went out to lunch with an individual who was a coach, a personal services coach, and I thought we were going to have a conversation. We went, and he was pretty much paying attention to how I responded to the way he ate and so forth. That includes things like changing the order. That includes things like ordering desserts, ordering drinks. And what he was trying to teach me at that particular time was, if he orders dessert, you order some dessert too, whether you want it or not, because it gives you more time with the client. I didn't, and so now he remembers me as the guy who made him eat dessert by himself.
Some of us would, relish the idea of having to eat dessert. And I think the flip side is just as true if they need to get out quicker and they don't want to hang around and they pay the bill very quickly, you need to be able to be sensitive to that and realize it's time to get back to work now.
Oh, absolutely. Absolutely. You're going for being able to understand that individual that you're working with so that you can let them be the good host. And that leads me to the third item on the list, and it is a habit, part of the 7 habits, and it's something that we should all think about more often when we're trying to conduct our meetings, talk with one another, provide that service, that better service. And that is seek first to understand, then to be understood. All too often, you start into a conversation at a meeting or sitting around a table with folks, and you're thinking about how you're going to respond rather than trying to actually listen to what that individual has to say. I can remember one time that I sat down and I was trying to convey a thought to somebody about how I felt about a situation. And I didn't even finish my sentence, and the response was, "Oh, I know. I've had the same feeling." And then they proceeded to tell me all about their feeling, and I never got my point across. And that's the kind of thing we need to avoid. We need to sit down and actively listen to what it is our client has to say, what their needs are, how they feel about things, and then we can actually have a better way of reaching out to them and sharing with them what we need them to understand in terms of providing that service. It's all about making that individual feel comfortable, making that person confident in the fact that you care about their needs. And if you can't do that, you're not going to be able to provide good service, I don't think. How about you, Keith?
Oh, I agree on that. Well, a couple of points. One, a while ago, I was interviewing a lady by the name of Elaine Rogers out of Ireland, and she's a coach, a business coach, a communications coach. And one of the topics that she covered in communications was that exact thing. Now, she didn't say seek first to understand before being understood, which, Stephen Covey did a good job of encapsulating it in just a couple of words. But it is do the listening part, and it's hard to do the listening because you want to talk. And we as IT guys, especially when we're speaking to some non-IT folks, want somehow to impress that we have the skills and we have the understanding. And we're thinking about what's the next thing I'm going to say, when really what we should be thinking about is, what's the current speaker saying, to understand that first before you try to blurt your little bit back. It will make our communications go a lot better.
Right. And you will ultimately provide a better service because there won't be a misunderstanding. You'll be able to provide exactly what they were looking for by simply listening and paying attention to their needs.
And we do have that active listening feature where you try to, maybe reflect back to what they said and tell them what they said. I found that sometimes that works if you're really good. Sometimes if the person knows about it and they just go, "You're doing that reflective listening. Stop that. Just listen to me." Okay, it's right. My wife, I know, but but it can be annoying if you do it, pedantically. But what you need to do is just make it organic. And as they say something, you kind of rephrase it to make sure that there is understanding before you move on to your point.
Correct.
Well, great. We appreciate you spending some time here today. We talked about a couple things. One, making sure you dress appropriately for the client. And you'd mentioned shoot for, the first time perhaps be a little better dressed than you need to be, but learn from that experience. And next, you talked about how to be a good guest and make your host feel like a host, which will engender you to them at the time and make them feel better. And the last we covered was seek first to understand and then be understood, a quote from Stephen Covey. Any last thoughts you have here, Ed?
No, I think that was a good start, and I look forward to future visits with you, Keith. This was really nice, and I hope to do it again.
Great. Is there any way, Ed, that we can contact you? How would you like to be contacted? And we'll put the info in the show notes. Oh,
that'd be great. Yes. Anybody has any additional questions about this or business continuity consulting, feel free to reach out to me. The email's in the show notes.
Thank you very much. And we'll see you next time.
All right. Thank you.
Thanks for coming and listening to episode number 4 of Wireless LAN Weekly. We're glad you were able to attend. A little review here. We covered high-capacity Wi-Fi with Jon Freeman, and Ed Schlichtenmyer just finished up on delivering better service. We're glad for all of their help and all of the contributors, Joel, Avert, as well as John and Ed, who have helped us out today. If you have any questions, you have any feedback, feel free to leave a message at the feedback line, either dial the number on the screen, or you can also just send us an email. Thanks for joining. We'll see you next week.
Wireless LAN Weekly, a podcast focused on the needs of wireless LAN professionals. We look forward to your feedback. Please leave your comments at the bottom of the show notes, or email feedback on the show can be sent to feedback@wirelesslanprofessionals.com. If you'd like to leave a voicemail feedback, just call 24/7 and leave a message at 1-801-481-9018. Until next time, this has been another production of wirelesslanprofessionals.com, a place to educate, inform, entertain, and inspire.